Okay, I'm going to talk about angle of elevation and depression questions, which are just an application of finding sides and finding angles or right triangles. All right. So, what is an angle of elevation? Well, it's an angle created by looking up with respect to a horizon line or a horizontal line, and these are always dotted. Okay, just to keep our pictures consistent. So if we had like some building here and we had this animal over here, this is, if the animal's looking up to say the top of the building, the line of sight is where the looking is happening or where the object is or some sort, and the horizon line is here. And this is the angle of elevation. And I like to draw it as an arrow because it's a turning, right? You're looking from the horizon line, you're looking up towards your line of sight. Maybe there's another animal up here. Okay? An angle of depression is the opposite. You're looking down with respect to a horizon line. So let's now imagine that you're on top of a diving board of some sort, the pool, and you're looking down at some ducks that are sitting in the water for some reason. Your horizon line is still flat across, but your line of sight is at those ducks. So it's an angle down, and we can call it X or whatever. Okay? So horizon line, always draw, it's always dotted, it always is horizontal. But your line of sight is your final turning point, right? It's where your angle is turning towards. This could help us set up problems consistently. And you can see the right triangles forming, right? Like right here and like right here, you see? So those are very, very useful. So all your pictures will probably look very similar to one of these two. So I want to do 4 of these questions with you. I'm going to do these 2 and then 2 from the homework. And we'll do the same in class. Okay. A rabbit looks up and sees a hawk perched in a tree. Okay, we got a bird here. And the rabbit, of course, is on the ground. And it's looking up. So that's the line of sight. But the rabbit, it's on the ground, right? Its horizon line is right here. Okay. The tree is 35 feet tall. This angle is 40 degrees. Okay. How far away is the rabbit from safety at the base of the tree? So if this rabbit goes this distance here, apparently they're going to be safe at the base of the tree. So that's the mystery distance X. So we have a right triangle with 40, X, and 35. So if you think about which trig function to use, well, you have them all right there for you. Tangent is going to be the best option. Tangent 40 should be 35 over x. You can multiply both sides by x or cross multiply. We get 35 here. Okay. And just like we've done, you're going to divide by that entire tangent 40, because it itself is kind of its own object. It's multiplied to x, so we need to divide it. And if you type that in, you'll get 54 feet, I think. Actually, no, that's not right. We'll just let you guys figure out what that decimal is. Sorry, I changed the question a little bit from last time. So you remember you would type this into your calculator. For the sake of the video, I want to keep going, but you would type that in, okay? We got the Statue of Liberty here. So we got a little statue, a little person, a little statue, and we got this person who's on top of it, okay? And the height is 250 feet. Looking out across the river at an angle of depression, Okay, so they're looking out horizontally, but they look down at a 18-degree angle and see a ship coming into the harbor. What's the approximate distance from the tourist to the ship? That would be this distance here. And we could also fill in this side of the triangle as a parallel height. It's also 250. So from here, I see we got opposite over hypotenuse, which is going to be sine. So 250 over x. And same thing as the last time. We want to cross multiply or multiply both sides by x. They effectively do the same thing. Okay. And we would again divide to get our answer. So this is the answer. And I can say with certainty this is 809 feet. Okay. Let me do two of the harder ones in the homework here. A ladder is leaning against the top of a building. Okay. And the ladder is 12.5 meters long, and it's 3 meters down here from the base. See that right triangle there? What's the angle of elevation of the ladder to the top of the building? So the angle, this would be technically the ladder's horizon line, and the ladder is tilting up. Imagine if you had the ladder, face first on the ground, and you pulled it and you lifted it up. That's the angle of elevation, and we'll call that x degrees. Okay, so we don't have the opposite, so we're forced to use cosine. Cosine of x is adjacent over hypotenuse. And when you have the x inside, remember that's the inverse. Okay, so x is around 76 degrees. Okay, and let's look at another angle of depression question. So if a lifeguard is on top of this post here, and there's a swimmer over here, and you're the lifeguard, right? The lifeguard is doing the seeing, and they're seeing a swimmer at an angle of depression of 8 degrees. What is the horizontal distance to the swimmer? Well, this, how tall is that? It's 6 feet. Okay, we're assuming that the lifeguard being 6 feet, we're assuming that's their eye level, because unless we're told otherwise, we have to kind of assume that. We want this distance, so we'll call this x. Okay. So to me, I see a opposite and an adjacent. This is the hypotenuse. So this is begging for us to use tangent. So tangent of 8 degrees is 6 over x. So if I multiply both sides by x, I get this. And then if I divide both sides by tangent of 8, I get this, which gives me 42.7 feet. Okay? So this triangle is actually a little misleading. The triangle really looks like this. Right? Okay. Hopefully those problems don't introduce too much new. So the new challenge is just to draw the picture. But all the math we already have done.